Okay, so we're going to talk about similar figures, meaning geometric figures. And if I have similar figures, they are figures that have the same shape. Do that. Same shape. But may have a different size. Okay? And they can be anything. They can be a rectangle, they can be a triangle, they can be a circle, they can be any kind of a polygon. Okay, so if I have similar figures, they're going to have corresponding parts. So I would have angles in the same position for the two figures, and I would have sides that have the same position. Okay, so let's look at a couple, or an example here with a triangle. Okay, so I have two triangles here. They are similar. I have triangle ABC and triangle DEF. So my corresponding parts are sides AB and DE, sides AC and DF, sides BF and EF, BC and EF, okay? So those are my corresponding sides. My corresponding angles are A and D. Then I have B and E, and I have C and F, okay? So in this case, they're exactly the same size. So they're similar, but I can take one of them, say I'll take triangle DEF, and I can make it bigger by a factor of 2. Okay? So if I make it bigger, oops, don't want to do that. And I'll apply it. And I have just increased the sides by a factor of 2, but not the angles. Okay, so that's important. Corresponding angles have equal measures. Corresponding sides will have proportional measures. Okay, so back to our triangle, this side here that has points D and E in it is proportional to AB, but it's not the same size. It's increased by, we said, a factor of 2 there. Okay? So we can go ahead and start to use that. Now the angles, if angles have the same sides or same measures, angles with equal measures are congruent. And if I had sides of equal measures, they would also be called congruent. Congruent just means the measures are the same. Okay, so I can go ahead now and I can use this information maybe to solve some problems involving geometric shapes. So let's look at a couple. Let me draw a couple of rectangles here. So if I have a rectangle and I have a second rectangle that I will try and make a bit bigger, okay, and I will call them similar. Don't know for sure if they are, but I will call them that. All right, so if they are similar, then I can say that if this is 3 and this is x, and I know that this side is 12 and this side is 33, then I can find x using the similar rectangle. All I have to do is set up a proportion. Okay, so I would say, well, x over 3 is the same as 33 over 12. And if I'm going to solve that, I can multiply both sides by 3. So I have x is 99 over 12, or 8.25. Okay, so finding x is a matter of using the proportions of the sides. Okay, so let's look at another one. So in this case, I want to say, well, let me just do it with lines. I'll draw a trapezoid. Okay, and then I'll draw a second but smaller trapezoid. And I know that they're congruent because, or they're similar, because my angles, I'm going to say, are congruent. So this angle is congruent to this angle. Oops. This one here. And then I have these two angles that are congruent. Okay, so at this point I want to change colors. Then I have these two angles that are congruent. And then finally I have these last two angles that are congruent. That is not a right angle. Whoa, I want to zoom in to do that. There we go. Okay, so since I have angles in similar positions that are congruent, I can say that my figures are similar. And I know this one has a side of 10, this one has a side of 24, this one has a side of 5, this one has a side of x. I want to know what x is. So again, I can set up a proportion. 24 over 10 is proportional to x over 5. Solving for x, I get, let's see, that x is equal to 12. Multiply both sides by 5, and I've come up with x equal to 12. Okay, so that's pretty much all this is about, and we can work on some problems in class, so I'll see you then.